Welcome. How you doing? It's a pleasure having you, sir.
Well, thank you. Yeah,
The
pleasure.
kids are working very hard. Let me explain what they're doing. They're doing a little potpourri of what they have done through the whole year to explain to you what they have done since day one.
Okay.
So each lab is setting is regarding pertaining to the death of the person the way back to find out what are the consequences to that death, whether it was murder, whether it was natural causes, accident. So the kids are working very hard into that, and then each lab is triggered specifically to find out whether it's a medical or whether it's full play or whether it was accidental. So the kids you're welcome to ask the kids.
Sure.
The kids will explain to you all this wonderful technique that we have and all the experience they have. It's a pleasure having
All
you.
right, sure. Well, thank you. Well, ladies, tell me what you're looking at here.
Well, in this experiment, what we're doing is we're trying to figure out the time of death in which the approximate hours since your death. And so the glacier equation is 98.4, which is the natural human body temperature, minus the rectal temperature at the time in which he was found, divided by 1.5, because that's how much the body drops each hour after being dead, and that would be the approximate hours of death. And so our experiment is we filled about 1.1 milliliters of polyacetyl, the same fibers that you could find in a diaper in order to absorb the wetness. We added about 20 milliliters of cold water in this one, and then a cold brew.
Hot water in this one. And then connected is Oliver-Wynn, and it's telling us the temperature as it drops down.
Okay.
So this one is, that one's connected to cold, and this one is connected to hot.
And so from the time it was started,
And then from the time that this one was started,
its original temperature was 6.2 Celsius, but it dropped down to about 5.5 Celsius within the course of 9 minutes. So we're going to be doing this for a total of 20 minutes. And for the hot one,
I'm trying to get it to spray.
Now, with this, each of your experiments, are you connected to another team? Are you?
well, each experiment is designed to enable to investigate how she died. And so this is just to determine her time of death.
Okay, so you're doing time, but I'm guessing what you're looking at one body, and somebody else is over there looking. Are you connected to the same body on each one? Okay, so it'd be the same person. Okay, all right. Okay.
When this first started, the temperature was 39.6 Celsius. And then after just, I want to say 10 minutes now.
I need, as I say, for 3 other courses.
10 minutes, the temperature is now 37.9.
Okay. So you do this for 20 minutes.
Okay.
Okay.
Yes.
Now, would this be standard procedure? I would say, if you were in the, I guess, either coroner's office or
Yes.
Right, so all this kind of plays in, or either in the investigation on a police department, they would use the same procedure with that as well.
Yes.
Okay. Well, very good. I wish you the best in finding out what time this person is deceased. All right?
Thank you.
Ladies, what are we looking at here?
Yes.
Okay. What do you hope to determine with
Well, basically what we're doing is we're taking Gatorade and we're putting it in our mouth and we're swishing around with toothpicks to spin around so we get parts of our DNA. We'll spin it back and then we'll mix it with alcohol and detergent. And so hopefully you'll see strands of our DNA in the afternoon. 6, all that, we'll see our strands.
Okay. Now, how long would it take to do this part of the procedure?
Well, we just got done swishing around our mouth, which took 1 minute. We did that for 1 minute, and now we're about to mix the other stuff with it. And we'll just let this sit for a little bit.
Okay.
Trying to determine the DNA that was found in the crime scene, whether it was for Ana Garcia or anybody else, any of the four players.
Okay, so we're gonna pour this into, so grab a flask of detergent.
We took bacteria off of, we smelled the water fountains around the school, and it was interesting. And
Did you find out which ones you you want to drink out of and not drink of? None of them. Okay.
But they were really bad. I wish I had some pictures to show you. But most of them were sort of like this. And then over the holidays, we bought a UVC wand from Home Depot, and it's usually used to go over beds and things to sanitize them.
Yeah.
And it went from basically like this to like this.
Okay.
So it decreased. It decreased at a linear rate, but grew back at an exponential. So we might need to use something else, or maybe do the process more frequently with the UVC one. But I think it's really a great idea to sanitize things around the school with the UVC one instead of just spraying, anti-sanitization thing. So I feel like UVCs would be a lot better and a lot cleaner.
Okay. Now, what you're testing, so you're not testing water quality, but just residue on that. So what you touch, and
Yes,
whether it could be
especially
the
around the
handle
cold
or
season.
Okay. Yeah.
They were really bad, and we used them to count on the colony counter.
Okay.
Yeah, basically what you do is when you turn it on, you can look closely.
Looking at the density, is that per square?
Yeah.
Okay.
And then you get to count each particle inside one square, and then count how many squares there is in like one container, and then you just basically multiply it, to get your result.
Yep.
Okay.
So then you would just add that as a per colony. And how we did it was we took the amount in each colony and then we averaged it out over one day.
Okay.
And that's how we got our graphs, and it showed that the graphs looked like, you would think it's a steady decrease, but since it multiplies back, it kind of looked like it would go down and then back up and then down and back up. So really you just have to be consistent with it and just keep going until the bacteria finally decreases enough for it to be healthy.
Yeah.
But they think it's healthy right now. So.
Right now, it looks like you have quite a healthy colony. there.
Yeah,
So,
yeah.
Okay. Oh, that's very good. That's exciting.
Yeah. Thank you. Have a good day.
Thank you.
Like a 60-minute glucose.
Well, ladies,
Hi.
what are we looking or determining here?
We're comparing the insulin and glucose blood samples from Anna Garcia and a patient.
Now, what do you hope to determine, or why are you, exploring glucose and insulin? What's the significance there?
We're seeing if Anna Garcia had type 1 or type 2 diabetes to see if that had an effect in her death.
Okay.
So we do the measure the insulin and we measure the sugar. And as you know, the insulin is in relation with the sugar. Without insulin, the body cannot absorb the sugar. So therefore, if the insulin is steady, that means that she's diabetic type 1. She cannot produce insulin. If the insulin goes up and down, it means that you're diabetic type 2. Because if in 2 hours you have not eliminated all the sugar you have consumed, it means that you have diabetes type 2. The insulin is not producing enough, or it's not productive, it's defective. So that's the difference between type 2 and type 1. And Anna Garcia, they're trying to determine whether she's type 1 or type 2 because some of the autopsy report recorded size of very high levels of sugar in her blood. So they're trying to see whether diabetes actually had anything to do with her death, whether it was accidental or whether it was
Diabetic shock or something?
Exactly.
Okay.
Did you do it?
Yeah, I
did. Jar? Huh? Do you need that?
This is here. The ladies can explain to you what it is.
Okay, this lab is about sickle cell anemia. So what we're looking at in here, this is regular human blood, and that's iron deficient blood.
Okay.
And you can actually look in this telescope here. And iron deficient, usually in iron deficient blood, the cells are a little bit weaker. And if you can see the purple stuff,
Yes,
those are white blood
Because
cells.
hemoglobin, which is what helps transfer oxygen, requires a lot of iron. So that's why iron deficient blood is weaker.
Okay. Now I saw very few purple or white blood cells there.
Right.
And over here we have a white blood cell. This one, if you like.
Okay. So what, at the end of the day, when you look at this information, what are you hoping to find?
Well,
Determine.
what we're hoping to find is during the case of Anna Garcia, in her autopsy report, it says she uses the medicine to treat sickle cells. So what we're looking for in her blood is the sickle-shaped cells, which are usually clogged with disease, and it stops your blood from flowing to make you really sick. So when we look at her blood, that's what we're finding, little sickle. They're shaped like bananas.
Yeah, okay.
Yeah, that's how you know if they're sickle cells.
Yeah, okay. Very good. Well, I hope y'all determine the cause of death there. Right, very
Thank
good.
you.
Thank you.
This apparently is supposed to be the crime scene. In her house, and it was found that we don't know whether it was foreplay because there were certain things that were actually in the home that was mysteriously. So they wanted to figure out by the height of the table of the when she came in here if that's the diameter of the actual blood or if she was hit full blown to the head at her height. They know their height, so they're comparing the height of the blood from there or the height from the blood to re-imitate or recapture again the sequence to compare whether the diameter of the cells match each height. The highest thing that she was attacked, hit by the top of her fight for her side. So if it is by the height of the table, then that means that it could be that she fainted or fell and tripped, and that was what
Fell on the table?
that was
Okay.
the blunt of the head. So that's why they're determining they're letting for it to dry the measure, and they, as you see, they're writing down the height. So we have repeatedly done this, and I try to update it. That's my other class. You do not have time to see it today. They were yesterday. Medical because that's epidemiology. And then we study every single disease that actually affect today in society in the world. And then we study to a family in the cases from genetic diseases to diseases that are passed on by like sickle cell, cystic fibrosis, DNA, inflation, anything that is being passed in the family. And we will eventually, at the end of the course, we will, all of them will specifically have what disease was passed on by and from whom.
Okay.
And if that is an actual family or somebody else is not belong there. So it's all DNA, it's diseases, bacteria. The first cause, if you notice, we have the statistics of the outbreak was an investigation of the outbreak in a college campus. One of the daughters is actually go to the campus and have meningitis. So we go through a series of dilutions, calculations, analysis, statistical analysis, calculating the growth of the bacteria with experimental log actual ratio. These are the bacteria we actually cultivated in here, that are over here on the side, and they are actually showing the hours that they reproduce the disc for the actual antibiotic, which one antibiotic will we prescribe. So we are actually the doctor that will be prescribing antibiotic. Those are the formulas that we use from standard population to standard deviation to size sampling. So they are actually the formulas that today we use in research. I did research for quite a while before I was a teacher.
Okay.
And epidemiology is my baby and microbiology. So I did a lot of that. I worked for different offices, governmental offices, and it's not educational appointment, but it was like CDC and under CDC and then food and drug administration.
Okay. Now, with these young people, they want to pursue something. What are my career options? Pursuing this?
Oh, I'll address that. How long do you have?
Okay, so quite a bit. Inlands there.
I tell you, anything that is forensics, pathology, forensics, psychology, because we also cover psychology, psychopaths, serial killers, anything that it is from epidemiology, medicine, anything that is in biomedical engineering, anything regarding to even research, setting associates for research, reading the book for food and drug administration on the research is a long extension, but they are all being trained with every single lab that we target with in ninth grade or in kindergarten, and you see, you might say, you know, when I was like that, my son is instruction in 3D printing. And then it's doing it is lighter. The child will not be heavily strapped, so it's more mobility, and it will. Is the child that needs it because it costs $50,000 to $60,000 every 2 years? You have to replace that prosthetic device because the child is growing. So if we can do it $250, that child has a $250 hand that is lighter, is easy to take off, doesn't bother her, and is affordable for whoever wants to donate it.
Yeah, 250 versus 50,000.
Yes. So we call it the hero behind the heroes behind the hero. So it's supposed to be like Captain America for boy, or it's Mulan for the girl. So it's targeted to the actual child with the colors that they want their superhero. So we are the team behind the hero. So
I like that. That's good. Yeah.
So I had a lot of tricks in my head, and then I try to be wherever I can because I try to help the nurse with the we have a lot of children in Georgia Tech that are back and forth going in research for diabetes, and also in research for the prosthetic device in Georgia Tech. So we're creating for the prosthetic, we're creating an app for the formula that is a review for the AP history. And they have done everything in the entire scope, like all the bacteria and era and time that have attacked at that particular time in the history of the United States. So it was George Washington was a smallpox. George Washington suffered from the smallpox himself. And he knew that would be devastating for his country. He will reach the end. So how he strategically in the North Coast. So they were not contaminated. So they will pass the contamination and survive. They were allowed to come to the school, so they were not in the schools. So in that way, he slowly introduced the smallpox because the police had that event. They were survived all the smallpox, so they will not die. They will not be contaminated. They will so they have, with each of those products that they're doing, they have the evolutionary era, the gassing, so Rockefeller was gassing as a byproduct, and he were taking it in the water. So they're exposing every single disease that it has done in each era in the United States history because they are combining I don't think I didn't want to let the beginning. But you're welcome to that.
Give me a little bit more Gatorade.
So you have a program that is amazing. The program does open their mind. This program is for individuals that think out of the box. Today, you gotta think out of the box. I have been out in the medical world. I have been also in the research world, and you cannot think in the box. You have to think out of the box. So for this program to be taught, have to be a person who thinks out of the box. It's all based on projects, and each idea is a project. Go ahead, fuel, give it the fuel. This is my stage. The children perform, and I'm just simply supervising, steering it, but let a plethora of learning in here. So they are more confident.
I'm asking Brandon, do you want to get a picture of that?
So you got a picture. So what is it? I just thank you for allowing me the opportunity to use my experience and to teach these children and guide them to a future without.
Do you have Zoom, like good Zoom, like I can camera?
From California. My father was Army, and I grew up in here. So I learned French, Italian, Spanish, my language. Yo parlo Italiano and some other languages. But I'm U.S. proud to be U.S. Thank you, ladies and gentlemen. It's nice to be an honor again. Thanks very much for coming tonight. Humble classroom. Thanks for supporting our program, sir. Thanks. At my heels to kill. So we have repeatedly done this, and I try to update it. That's my other class. You do not have time to see it today. They were yesterday. Medical fiction, that's epidemiology. And then we study the single disease that actually affect today in society and the world. And then we study through a family in the cases from genetic diseases to diseases that are passed on by like sickle cell, cystic fibrosis, DNA, inflation, anything that is being passed in the family. And we will eventually, at the end of the course, all of them will specifically have what disease was passed on by and from whom.
Okay.
And if that is the actual family or somebody else is not belong there. So it's all DNA, it's diseases, bacteria. The first cause, if you notice, we have the statistics of the outbreak was an investigation of the outbreak in a college campus. One of the daughters is actually go to the campus and have meningitis. So we go through a series of dilutions, calculations, analysis, statistical analysis, calculating the growth of the bacteria with an experimental log actual ratio. These are the bacteria we actually cultivated in here, that are over here on the side, and they are actually telling the hours that they reproduce, the disc for the actual antibiotic, which one antibiotic will we prescribe. So we are actually the doctor that will be prescribing antibiotic. Those are the formulas that we use, from standard population to standard deviation to size sampling. So they are actually the formulas that today we use in research. I did research for quite a while before I was a teacher.
Okay.
And epidemiology is my baby and microbiology. So I did a lot of that. I worked for different offices, governmental offices, and it's not educational department, but it was like CDC and under CDC and then food and drug administration.
Okay. Now, with these young people, they want to pursue something. What are my career options? Pursuing this?
How long do you have?
Okay, so quite a bit. Inlands there.
I tell you, anything that is forensics, pathology, forensics, psychology, because we also cover psychology, psychopaths, serial killers, anything that it is from epidemiology, medicine, anything that is in biomedical engineering, anything regarding to even research, setting associates for research, reading the book for food and drug administration on the research. It's a long extension, but they are all being trained with every single lab that we target with is in 9th grade or in 10th grade. And my seniors, you know what it is lighter. The child will not be heavily strapped, so it's more mobility, and it will. Is a child that needs it because it costs $50,000 to $60,000 every 2 years. You have to replace that prosthetic device because the child is growing. So if we can do it $250, that child has a $250 hand that is lighter, is easy to take off, doesn't bother her, and is affordable for whoever wants to donate it.
Now, 250 versus 50,000.
Yes. So we call it the hero behind the heroes behind the hero. So it's supposed to be like Captain America for boy, or it's Mulan for the girl. So it's targeted to the actual child with the colors that they want their superhero. So we are the team behind the hero.
I like that. That's good.
So I have a lot of tricks in my head, and I try to be wherever you can. I try to help the nurse to let you know to get it. We have a lot of training in Georgia that are back and forth going in research for diabetes, and also in research for the prosthetic device in Georgia. So we have we're creating for the prosthetic, we're creating an app for the formal that is a review for the AP history. And they have done everything in the entire scope, like all the bacteria and era and time that have attacked at that particular time in the history of the United States. So it was George Washington was a smallpox, George Washington suffered from the smallpox himself. And he knew that would be devastating for his country. It will reach the end. So he helped him strategically in the North Coast. So they will not contaminate them. So they will pass the contamination and survive. They were allowed to come to the school, so they said they were not in the schools. So in that way, he slowly introduced the smallpox because the British had that event. They were supervised all the smallpox, so they will not die. They will not be contaminated. So they have, with each of those products that they're doing, they have the evolutionary era, the industrial era, the gasoline, so Rockefeller was gasoline as a byproduct and history taking it in the water and the soil. So they're exposing every single disease that it has done in each era in the United States history because they are combining I don't think I will answer the beginning. But you're welcome to that.
Give me a little bit more Gatorade.
So you have a program that is amazing. The program does open their mind. This program is for individuals that think out of the box. Today, you gotta think out of the box. I have been out in the medical world. I have been also in the research world, and you cannot think in the box. You have to think out of the box. So for this program to be taught, has to be a person who thinks out of the box. It is all based on projects, and each idea is a project. Go ahead, fuel, give it the fuel. This is my stage. The children perform, and I'm just simply supervising, steering it, but let a plethora of learning in here. So they are all confident.
Brandon, do you want to get a picture of that?
So you got a picture. So what is it? I just thank you for allowing me the opportunity to use my experience and to teach these children and guide them into a future without.
Do you have Zoom, like good Zoom, like African?
From California. My father was Army, and I grew up in Europe. So I learned French, Italian, Spanish, my language. Yo parlo molto Italiano and some other languages. But I'm U.S. proud to be U.S. Thank you, ladies and gentlemen. It's nice to be an honor again. Thanks very much for coming tonight. Humble classroom. Thanks for supporting our program, sir. Thanks. Got my bills to kill.